For my first problem, I'm going to be doing number 5. So to start off with, we know that nothing needs to be factored, so let's just get right into it and do our zeros. So in order to find our zeros, we have to set the numerator equal to 0, which because that statement's not true, we are left with none. And for our vertical asymptotes, we set now the denominator equal to 0, and once you find this, we know that we are left with x equals -2 and x equals 2. Now for a horizontal asymptote, because the degree in the numerator is smaller than the one in the denominator, we know that we are left with a horizontal asymptote of y equals 0. And we have no oblique asymptotes because the numerator is not greater than the degree in the denominator. So we simply just put none. And for the holes, because there were no omitted points in the graph, is also none. And now we just need to find our domain. In order to find our domain, we just need to do a quick sketch of the graph. So we are just going to input this into a graph, which I've already gone ahead and done. And once we do so, we graph it, and we see that our graph should look something like this. So let me just put in what we know so far about the graph and then go ahead and draw it. So we know that we have vertical asymptotes at x equals -2. So we're going to put this one somewhere around here. And this is x equals -2. We know we have another one at x equals 2. So this is x equals 2. And now we have a horizontal asymptote straight across through our y. And this is y equals 0. And now we have no oblique asymptotes or anything like that to worry about. So now we can just go ahead and graph it. So this one is going to go from here to here. And then again, from here to here. And like so. So now let's just find the domain, and so we can see that the domain goes from -infinity to -2, and there picks back up again at -2, which are asymptotes, to 2, and there picks back up again at 2 to infinity. For the last one, we're going to do number 8. So I can clearly see that I have to factor the denominator, and once we do that, I know that it's going to be over 1, and I'm going to be left with 4 times 3 minus x and 3 plus x. So now, to find our zeros, we have to set the numerator equal to 0, and we can clearly see that since that statement's false, we do not have any zeros. So we just put none. And now for our vertical asymptotes, we do the same thing, and we set the denominator equal to 0 now. And we are left with an x at 3 and an x at -3. And now for our horizontal asymptote, because the numerator's degree is less than the denominator's degree, we are left with a horizontal asymptote at y equals 0. And for the oblique asymptote, because the numerator degree is not greater than the denominator's degree, we do not have one. So we simply put none. And now for the holes, because nothing was omitted, we also have none. And now to find our domain, we just need to do a quick sketch of the graph. So I'm just going to go ahead and put down what I already know so far about the graph. So I know that I have vertical asymptotes at both 3 and -3. So we're just going to put them somewhere around here. And we are going to call this one x equals -3. And then we have another one here at 3. This one is x equals 3. We have a horizontal asymptote straight across to y equals 0. This is y equals 0. So now just to put it into our graphing calculator, which I've already gone ahead and done, and then we graph it. And it looks like two little lines, but if we go ahead and fix it and we do zoom fit, we can clearly see that the graph, it's a U and it has two lines. So we can now just go ahead and draw this. We have a parabola up here and two arrows that never cross the asymptote lines, like that. And now we just need to find our domain, and we can see that our domain goes from negative infinity to -3, ends there, picks back up again at -3, and then ends at 3. So -3 ends at 3. And then it picks back up again from 3 all the way to infinity. Here we go, that's it.